By its spin. The third stage fires and gathers speed. Then it too burns out and ejects the satellite into orbit at 18,000 miles per hour. The speed at which the satellite's movement forward matches its fall toward Earth and thus keeps it in orbit. 300 miles out, beyond the dragging effect of the lower atmosphere, it continues to move at its original orbital velocity. Depending on their orbits, some satellites circle the Earth about once every 90 minutes. Others may take hours more. Satellite orbits, like those of the planets, are elliptical, with a far point, the apogee, and a near point, the perigee. After many such orbits, most satellites encounter enough atmospheric drag at perigee to slow them up a little. This drag eventually causes them to plunge into denser atmosphere and be burned up by friction. With a high enough perigee, some satellites will remain in space virtually forever. 2 years after the earliest successful launching, a number of unexpected but very significant findings were made. 2 of these were made possible by precision tracking. The first finding, interpreted from tracking data of Vanguard 1, provided new facts about the shape of the Earth, facts that could be obtained only from a satellite. Minute differences in the repeated measurements of Vanguard 1's orbit led scientists to believe that the Earth's gravitational effect on the satellite varied in certain areas, and thus the distribution of the Earth's mass must vary. These variations caused scientists to change their concept of the Earth's shape. Greatly exaggerated here, the differences between the old outline and the new slightly pear-shaped one are actually no more than about 50 feet in certain places. But this refinement, however small, is of great importance to a better understanding of the nature of the Earth's crust and interior. A second major finding was obtained from studying the slowing down of Vanguard 1, caused by atmospheric drag. This graph indicates how the drag on the satellite increased substantially following flares on the sun. This finding led to a new theory. Charged particles streaming toward Earth after solar flares increase atmospheric density enough to affect a satellite's orbit.